Welcome back. Today, we're tackling a really interesting problem. Given a number, we want to find the smallest number whose digits multiply together to equal that number. This is a unique way to reverse engineer numbers and can be surprisingly tricky. Let's dive in. The idea is rather simple. We first break the number down into digits so that when multiplied together, they equal the original number. If it is impossible, like 129, we return 0. Notice that we want the smallest number possible, so the order of digits matters too. We start by checking if the number is less than 10, which is simple. Then we try dividing the number by digits 9 down to 2, and then collect the divisors. If this process n isn't reduced to 1, that means it contains either a prime factor bigger than 9, so there's no solution. Finally, we build the smallest number by arranging digits in ascending order. The key steps are factorization and ordering. By dividing from 9 down to 2, we ensure the smallest possible digits end up on the left when we rebuild the number. This guarantees overall number is minimal. Looking at these examples, you can see how different numbers break into factors. 100 splits into 4, 5, and 5 to give the smallest number, 445. For 129, we can't split it into the digits below 10, so the function returns 0. This approach is rather useful in educational apps or coding puzzles. It can also help teach factorization in a fun way, showing how numbers can be broken down into smaller parts creatively. We've learned how to calculate the smallest number whose digits multiply to a given number. By carefully factorizing and arranging digits, we can efficiently find the minimal solution to or determine if no solution exists. It is a smart combination of factorization and number construction. Thank you for watching. If you enjoyed this video, please make sure to like and subscribe for more JavaScript tutorials. I'll see you in the next one.